Hello बच्चों, let's read the question. The question says Mg can reduce NO3 negative to NH3 in basic solution, and the reaction is given NO3 negative plus Mg solid plus H2O gives MgOH whole twice solid plus OH negative aqueous plus NH3 gas. A 25 ml sample of NO3 negative solution treated with magnesium. The NH3 gas was passed into 50 ml of 0.15 normal HCl. The excess HCl required 32.10 ml of 0.10 molar NaOH for its neutralization. What was the molarity of NO3 negative ion in the original sample? So let's see the key concept to this question. Key concept to this question would be N1V1 equal to N2V2. That is, for a reaction, for a redox reaction, gram equivalents of reactants should be equal to gram equivalents of number of gram equivalents of product. This is the general normality equation. How things are happening, like we have a beaker. Okay, in this beaker covered with something. This beaker is covered and it has a single passway from where ammonia can pass, and we will connect a tube here and connect this tube, dip this tube in another beaker which will be having 0.15 normal HCl. Okay, as soon as ammonia is liberated from this solution, it will pass into this solution of HCl, and since ammonia is basic in nature, ammonia is basic, so it will neutralize the HCl, and after neutralization we will take this HCl and check its molarity, check how much it is neutralized. And from here we will get to know that how much NO3 negative ion were there in the solution. So let's start the question. Since milli equivalents of NH3 formed in the solution would be equal to milli equivalents of HCl used. Now for milli equivalents of HCl used, we will be milli equivalents of HCl used would be equal to, since we have 50 ml 0.15 normal HCl solution, so number of gram equivalents would be in this solution would be equal to N1 into V1. Let's take N1 equal to 0.15 and V1 equal to 50 ml. These are the total number of gram equivalents, and since we are left with some gram equivalents, like further base is needed to neutralize the remaining HCl, so the milli equivalents of HCl used for neutralizing that were neutralized by ammonia will be N1 V1 minus let's say this is N2, which is equal to 0.10 normal. This is NaOH, and let's take V2 as equal to 32.10 ml minus N2V2. Okay, now by putting the values we will get 0.15 into 50 minus normality of second solution is 0.10 multiplied by volume, that is 32.10, and this value comes out to be 4.29. These are the milli equivalents of ammonia released in this beaker. Milli equivalents of NH3 released. Okay, now since for this reaction NO3 negative is getting converted to ammonia, so the oxidation number change would be +5 to -3, that is 8 electrons are being gained here, so the N factor for the reaction would be equal to 8. Okay, now since milli equivalents of NH3 for valence factor 8 would be equal to 8 multiplied by 4.29, that would be equal to 34.32. okay, now these are also milli equivalents for milli equivalents of NO3 negative. Okay, because these both will be equal, these are of the reactants and these are of the products. Now since normality of NO3 negative into volume would be equal to number of gram equivalents, that is 34.32. now since volume of the solution is 25, so divide by 25 and we will be getting normality of the solution. Okay, and this value comes out to be 1.37. now as we know that normality is equal to molarity into N factor. N factor for this reaction is 8, so molarity of NO3 negative solution would be equal to 1.37 over 8, that is equal to 0.1716. okay, so this is the final answer to this question. Hope you understand it well. Best of luck.